Can I have a big hand for Mathieu?
Thank you. All right. All right. Let's wait until it appears over there. But first, I want to say a big thank you to the organizers for having me and having all of us here. It's been a really, really nice conference. I'm really happy to see a different conference, something that really brings joy and different perspective to what we do, to our craft. Sorry, if I can get the slides up here. The title of the talk is We Don't Make Mistakes. We have happy accidents. We don't make mistakes, we have happy accidents was repeated by Bob Ross. Bob Ross was the host of a TV show called The Joy of Painting. No mistakes. Perfect. All right. So we don't make mistakes. We have happy accidents, and it's just one of them. Nothing bad happened. That was something that Bob Ross repeated. He was the host of a TV show called The Joy of Painting, during which, for every episode, that lasts 30 minutes, he was painting from scratch a new picture every day, using the same palette of colors, very limited, but he would do so with such joy and empathy that it would make it seem easy and simple to own a craft and to learn how to paint and enjoy it. And this resonates very much with me, and I hope with you as well. This idea of not making mistakes and just having happy accidents and going with it is really, really a really joyful approach to any craft, painting, programming, woodworking, anything. My name is Mathieu Henry. I go online as P01, and I am a software engineer at Microsoft, but I have a background in Demoscene, and I run a code club for the past few years. The talk for the next 30 minutes will go through these technical facets of my life. Then I will do a little bit of live coding, and then I will see about how we can bring this home somehow, and then we will head off to have drinks and a party. All right. So I joined Microsoft 6 years ago after spending a long time at a browser company, Opera Software. And it was, well, Microsoft had a bad rap before, but they have changed a lot. And I'm really happy about the new direction that they have taken the past 6 to 10 years. When I joined, actually I joined because I had many friends who went from this browser company to Microsoft, and they kept telling me about how things were working there, and that but they take care of each other and they take things seriously, things like GDPR, privacy, compliance, and all of these things. So to be honest, Microsoft 10 years ago was maybe in my blacklist. I would not have signed for Microsoft 10 years ago. But 6 years ago, they had changed so much that I was sold after one coffee with them. Yeah. So when I joined a feature team that was working on this card that you show some information when you see the picture of someone or the name of someone. So we worked in a small repository, and then it grew. We added new features, more things came into this repository, and things grew quite a lot. And then this became like a big mono repository. 3 years ago, I switched to more of a developer experience team. And now this repository has about 1,000 contributors, like 500 really active contributors and 1,000-ish that contributes a little bit more seldomly. We have over 1,200 packages, like in the NPM or NuGet sense. There are a lot of code in these 1,200 packages. Some of them are actual applications or consumed in host applications. And these actual applications and host applications make up about 80 apps. Some of the code in this repo is consumed in Word, Teams, Outlook, Bing, yeah, you name it, everywhere. And most of the code is in TypeScript, targets the web, obviously, but we also compile to Windows, Mac native applications, Android, iOS, and also Electron and web views. So there's a lot going on. With regard to the developer experience, which I focus on, there's a lot going on about the security, the privacy, and compliance of the data of the developers, of the users, what is stored, where, who has access to it. In short, I have access to nothing, obviously. Well, no one at Microsoft has access to your data. You only have access to data of your company, your entity. But also we have to take trainings, regular trainings. Like if I don't take a privacy training or security training every 3 months, I lose access to the code and I cannot work. It's that simple. So in the developer experience, we work a lot on the inner dev loop. So this is everything that people do, everything that developers do, like before they even submit a PR. Like, what is the experience of a developer to work in the editor, to check out a branch, check out the repository, to do simple Git commands. And then we also work a lot on the outer dev loop, like what happens when they submit a pull request? What is the experience there? What are the performance? I work a lot on test automation, especially on visual tests, and I did a lot of work about the performance of the visual test. We also collect a lot of telemetry of what is the experience for developers. How long do any Git operation take? How long does it take to run, to build any single package? How is the multi-threading of the building, and so on and so on. So there's really a lot. We have a rotation of on-call engineers because the team is really distributed. We get so many new people all the time. We have on-call engineers that are ready to help people like 24/7. We follow the sun and we have people online. Actually, this week I am on call during European daytime, but I have a colleague backing me up. And we also have a system of buddy. So when someone joins a team, they are assigned a buddy to actually onboard them, to help them with everyday problems, to learn all the jargon, all the acronyms, and bring them up. And also the system of on-call engineers really help bring up like all the people who join. Like it helps troubleshoot issues that people run into commonly. So it's really a nice way to level up everybody. And of course, you can imagine that we're only humans, we do mistakes, and things go sideways sometimes. But we learn from them. So when something bad happens, we make what we do, or what we call a root cause analysis, where we try to understand the root cause, fix the issue, and make sure that we don't repeat that again. And I said that, so that's my Microsoft asset. I said that I come from demo scene. The demo scene started 40 years ago with this picture. And that picture in itself is nothing much, but it's a statement. And that statement was, yes, we did this, but this statement became a full movement of people trying to push the artistic and technical boundaries of any platform. And nowadays, you can see example of demo scene productions from over the years. We get demo scene productions on all kinds of platforms, from computers from the 70s, 80s, up to modern machines, at all sizes. Because it started in the 80s, there was like technical constraints, like you could only make a program in 4 kilobytes, or 1 kilobyte, or 256 bytes. But now we have less limit, but people still play with these limits to actually feel or fuel their creativity. So this is really how I grew up. I was most exposed to the demo scene when I started on the Atari ST computer. You can see here in green the full resolution of the Atari, 320 pixels by 200. And that's all the pixels that you could draw. You could only draw inside these green pixels. Atari Corp, the manufacturers of this computer, said like, this is the low resolution You can draw in this green area, and that's all you can do. Except that if you look around here, at the bottom, left and right, demo makers found a way to actually do something that was supposed to be impossible. But the manufacturer of computer said it is impossible to draw outside of these boundaries. They found that if you change the frequency of resolution at a given position early, when the beam of electrons is early on the line, you actually trick the video processor into starting to display the memory on the screen. And if you do that a few pixels later, or clock cycles later, then you trick again the CPU, or graphic chip to not stop rendering. When I saw that, I was just mind blown. I was about 10 years old when I saw this, and I knew this constraint, and I knew it was impossible, and I was hooked. I have to understand how this works. These people are making things that are impossible. And this is what I'm trying to do with my personal projects. Here is one called Defender, the favicon, which I did a few years back. It's a remake of Defender, the arcade game, but you play in the favicon, the icon of the browser in the address bar. Some other projects that I like to do. Let's see if we get sound. If we don't, it's okay. Okay, doesn't matter. So this is really dark on the big screen, I'm sorry. Okay. Normally there's music and speech synthesis, and this whole thing is in 1 kilobyte of JavaScript as a single file. Yeah, that's the kind of thing that I try to do, I really enjoy. And yeah, I get to explore many things by doing this. Here's another project, much smaller, 256 bytes. It has some kind of 3D animations as well. And sometimes I play with sound as well. It's okay. You can find this on my website later. What this does is called Music for Tiny Airport. Is an homage to Music for Airports by Brian Eno, one of the first ambient music album that was made 42 years ago now. Except that this is the whole source code that you see in blue. It's 256 bytes. So in the demo scene, we typically don't make mistakes. We have happy accidents. Like when you program an effect or some animation, some music, well, you have bugs sometimes, but more often than not, the bugs are more fun, more interesting than what you were trying to do. So the adage from Bob Ross really comes at play here. And I was really exposed to the demo scene when I was about 10 years old. And at the time, I was going to a code club in my hometown. And I owe a lot to this code club because it really exposed me to programming concepts, to the demo scene, and to be here with you today. So 5 years ago, I decided to pay back, to finally pay back and open a code club at the school of my daughter. You can see her with the watch and the white sweater. And this is the code club that I run at her school. Now she's a bit older. We have children, or I have children from 7 to 11 years old. And the groups are 6 to 12 people, or kids, people. They are tiny people. Like Feline said earlier, that she grew up with like the basics, programming and so on. So at first I tried to go back to the basics, go back to the computers that I grew up with, because I think that these kids, like, they didn't even grow up with a mouse. They grew up with touchscreen. Like, they don't know how to use a mouse, and they take many things for granted. So I think it's kind of nice to bring them back to how it was, how simple things were when I was their age, when I learned to program. So we do this for a while. And then when we move to programming, I use something called Pico 8. It's a fantasy console by Joseph White. Fantasy console just means that it's a console that does not exist. Joseph White created some kind of emulator for a console that he wished he had, and there's the whole environment that you can see at the top, where you can program, create sprites, maps, sound effects, and music. It has a very small screen, 16 colors, very small API to do graphics and sound, and it's like a really small cozy space. Like you have like some constraints, but they're actually fun. So it's really nice to iterate. And he made a EDU version, education version, that pico-8-edu, that is for free, and you can really have fun with it. And there's also a tutorial on how to use it. So I try to introduce some people to children to tell them that we didn't get here by chance or just like this. There are many people who do cool things with computers, and one of them is Samia Halabi. She is 84 years old today. She's a painter, a teacher, and a creative coder. At the tender age of 50 years old, or 50 years young, in the mid-80s, she bought herself a Commodore Amiga. She was a painter and a teacher back then, but she bought herself a Commodore Amiga to create art with code because she saw this thing with personal computers as a new medium. And she was like, yeah, let's learn programming and let's express myself. So she made pieces on the Amiga. Here is one of them that I recreated on the Pico 8. It's called Rain. It's pretty simple, but it does like interesting things, shows some nice patterns. And I asked the children to have a go at it. And here is Rain, reinterpreted by one of the children. You can still see the spirit of Rain, but it's reinterpreted by this child. And it's probably one of the first programs that he ever wrote. And it was really nice. There was no mistakes there. It was perfect. Here's another one. Same. It looks still, you can still see the spirit of the original piece, but it was reinterpreted. And again, no mistakes. It's just different. It's just its own interpretation. Maybe with bugs, but who cares? So, and then we move on. We try to make games, because obviously they want to make games. So I usually try to prepare the code, and like I'm ready to give a session. Like, yes, today, kids, I did Tron and Snake, whatever you want to call it, and we're going to do this. And it's going to be cool. And then this is what we're going to do. And this is what we do. and I was like, okay, it's a million times better than what I did. And you're 8 years old. and I'm paid to write software. And here's a small video of one kid playing his own Tron game. And I don't know about you, but I want to play this game. It looks so fun. So in the Code Club, we really go by this. We don't make mistakes. We have happy accidents. There's no bug, but just happy things. Now you saw like 3 big aspects of my tech sides. Another one is that I like to live code. So that's what we're going to do now. Let's put the audio jack button. Should work. Okay, we don't. Thank you. All right. Okay. Is the text big enough for people in the back? Yeah, perfect. All right. So when I live code, I try to have the most simple setup ever. Just a web browser on the side and the editor on the other side. So I have this file called joy.html, which I open here, and the web browser with the DevTool open. So I just have a little bit of boilerplate, an HTML element with a radial gradient, just to have some color in the background, and HTML body and canvas that are position absolute to the top, no margin, and full size. So because I will use the canvas element to draw things. And then we have a body and a canvas, and we start with a script. And a list of emojis that Vida, my daughter, gracefully typed for us today. And she was really happy to do that. And some text from the joy of coding. So we'll do some kind of animations where we'll make these emojis dance on the screen and make them like have a rainbow glow. Because, yes, because have you seen the lanyards and it's Pride Month, everything? Come on. All right. So we'll start with, we want to get hold of our canvas. So we'll get a const we call C, and we do document.query selector on the canvas element. So now we have a canvas in the variable C. To draw on a canvas, we need to call the getContext method to get the 2D context on the canvas, because we'll do 2D drawings on it. You could do WebGL, like 3D on it. And I'll create a method called renderFrame. I will take the time in milliseconds as argument. And I will start by calling it at the beginning with no time. And I will just output the time in milliseconds, console log, inside my renderFrame method. So now we just get 0 in the console at the bottom, because we call renderFrame once. To render frames, or more frames, you need to call request animation frame, which is a browser API, to call a function at the next frame. So we do that, and now we get a loop, and now we see our time value goes up. This is good. Now let's do this on the canvas. But the canvas, we need to set its width and its height, and for that we will use the inner width, which I will divide by 2. Inner width is the inner width of the viewport, and the height, I will use the inner height, so the inner height of a viewport, I will divide by 2 again to have a bit less pixels. And I will set the canvas width to the width that I just computed, canvas height to the one I just computed. Set the fill style to white, and I will fill text this time in milliseconds at position 1616. So now I should get, in my render frame, I should get a canvas that is always sized to half the width or half the viewport and displays the time in milliseconds. Cool, that works. And we can remove the console log. Now the next thing we'll do is that I want to render these emojis. I'll make n like a count of emojis that I'll draw, say 32, and I will make a loop because I want to display more or many emojis. So my loop will take I from 0 to n, and when we do text, we need to draw, oops, sorry, emoji. So we use context, the fill text, the text, and then the coordinate x and y. We'll start with kind of type, sorry, emoji. I will start with 1, party, with 1 party emoji. The x at CY. I will draw them at the center, and yeah, just for the center, I will say CX and CY is the center X and Y, and just say CX is the width by 2 divided by 2, and CY is the height divided by 2. So now we should get a reload. Yes, I have my party emojis that is rendered in the center. Now I want to render many in different positions. So let's see what happens if I add I here. Yes, I get to a y coordinate. It increments, so I really see that I have more than 1 emojis. Let's draw them in circle. So we can do, to draw a circle, we need a radius, so to know the distance from the center. And the x and y coordinate, when we create or draw a circle, the x coordinate is the cosinus of the angle, and the y coordinate is the sinus of the angle. That's, yeah, That's the definition. It's we start with a radius that is like the width divided by 3, and I can do, for the x coordinate, I'll do from the center, I add r times the cosinus of the angle, and for the y coordinate, r times the sinus of the angle. Except that the angle, I have not defined yet. The angle would be I divided by n, so that brings which emoji I'm in. If I divide by n, that would be between 0 and 1. But the circle is in gradient, in radian, sorry. So if I do that, I just get like one portion of the circle. That's because cos and sinus use radians, and radians for a full circle, this is 2 pi. So math that pi times 2. Now we have a full circle. And if we remove, we just mess up with numbers like this, no mistakes here. Just what happened? Okay, this is a little bit crazy. But that's because the time is in milliseconds. It increases really, really fast. So if I just divide the time here by some number, things are a little bit smoother. Now, what if I change the size of these emojis? So let's say size, and that would be, the size would be based on r, the radius. And so I can do, sorry, trying to get my cursor to move. I will set the font size, or the font, to match this. Size is in pixels, and say monospace, doesn't matter much. Oh, this is, okay, this is big. And also something you can see is that the emojis are really like shifted to the left. That's because when I draw them, I don't draw them centered. So let's fix that. On the context, we say text align equals center. And same, vertically, we have to adjust the baseline. So let's text baseline. Set to middle. So now things we appear centered. They are really big. So if we do something that, if we try to apply a bit of perspective, and to do that, we can do our r, the size, we can divide it by, let's say, 4, so that makes it smaller. But if that 4, we change it to be, okay, let's say 3 plus the cosinus of the angle. So the angle on our circle thing, the angle goes all around. Sinus and cosinus, their values go from +1 to -1. So in short, this thing, like 3 plus the cosinus of the angle, would say from one side of this circle of emojis that are under to the other, this value in parentheses will go from 3 plus 1 to 3 minus 1, and will make like one bump. So that should give some kind of perspective. And yeah, it does. Okay. So now we have these, okay, always the same emoji. Let's try to use different ones. So we'll use the list of emojis that my daughter gave us. And then that's the emoji, but yeah, then modulo of length. So now we get cool animals. Yeah. All right. I said that I wanted to have some kind of like a rainbow halo. And we can do that by applying a filter on the canvas, just like CSS filters. So you can say blur, 16 pixels. So now it draws the emojis, but blurred, which is OK. And we can also apply another filter called hue rotate. And hue rotate will basically rotate the hue, like the colors along the color wheel. And we can reuse the angle that we have here. So now I shift the angle of the hue of every emoji along based on its position on the circle. If I mix in the time in there, time in a second, time is going to be a little bit crazy because it's too fast. But if I slow this down by dividing the time. Let's say divided by 800. Things shift a little bit better. And now, okay, it's all like a big soup of text, of emojis. So now if we draw them again, but with no filter, with none, it's going to look a bit cooler. And this thing, size, so now it's only basically some kind of perspective. We can multiply it by, so it's like multiplying by 1, but we can also multiply by 1 plus something that will move. Let's do plus 0.5 times, let's throw another sinus in there, A. So now things don't really change, but if we do A times 3, we should get like 3 lobes on this on the different size of these emojis. And we can also again throw the time in the mix. Let's divide by, yeah, so things are moving a bit too. Let's spend another like 2 minutes here to draw some text, the text that I had above here. And we'll do that by doing, first we set back the font because, let's not do it even. We need to know where we'll draw the text, and we'll draw it at the center. And the Y will be a let around the center, a little bit less than the center. So the center times 0.9. So it is just a little bit less. And when we'll do a loop, where we get one text out of all the text using this, we'll draw this text at the X and Y, so that will loop through all the text. So now this draws all the text but on top of each other. So if we just increase the Y coordinate, sorry, by 16-ish, things move. But it's a little bit chaotic, so let's also set the font sizes. So let's start with something bold for the first line, and then we'll put something italic, and yeah, well, it looks not too bad. Yeah, back to the slides. No, F11. So yeah, that was fun. There was no mistakes really. Like there was some bugs, but nothing bad happened. Just some happy accidents. So then you maybe wonder, okay, this is fun, but what about the practical applications of this? Like, it's fun in itself, and that's totally fine. It's a really good thing to do, but maybe we can bring that to work. So one of the practical applications you see right here, you see my photo, and in many applications you would see the photo of a user. But if that user doesn't have a picture, you will get something like this, like a circle with a color and the initials. This is cool, but yeah, I work at Microsoft, like a big company, like it's been around for 40 years. It has bought different companies along the way. All these companies had like users. Not all of them had user photos at the time. So all of these services or applications that have users, eventually they had to add user photo. And not all of them did at the same time, so we had to introduce some fallbacks. One fallback that was used is called this doughboy. It's like a white silhouette of shape of someone. The problem is that at Microsoft, we have many different services that did that at different point in time. So we ended up with, of course, we have different endpoints, like to call each service to say, hey, give me a photo of this user. Teams, give me a photo of this user. Messenger or Hotmail, give me a photo of this user. So we ended up with 8 different images that are 16 kilobytes in JPEG or PNGs, and it's tricky to detect this and know when we don't want to show this. We want to show these initials because it's nicer. It's more personal. So we need to detect this. And one way to do it is to create some kind of fingerprint, because we don't want to ship these 8 images and 16 kilobytes for every user in case they want to see the picture of someone that has one of these doughboys. So we don't want to ship all of that. So one idea that is smaller is to create, when we get a picture from someone, or we ask a picture of someone, we get something back. We want to basically get something that is really small that we can compare against. So we do some kind of fingerprint. We can get the image that or take the image we got back from the server, draw it on a canvas, ask the canvas, hey, you know what? Take that back into a PNG. Give me this PNG that you just encoded from the pixels I got. And then I will hash that, and I get a fingerprint. And then what we need to do is just ship the list of fingerprints from these 8 images. Easy. Except it's not, because every single browser, they have different JPEG decoders. The way a JPEG is decoded in all browsers and different versions of browsers changes over time. It's different. They have different PNG encoders. So when we ask Canvas, hey, from the same buffer of pixels, give me a PNG out of that. It also changes over time. So every time we have to change this. So we're like, OK, maybe we can do some image detection. And I spend a lot of time working on a visual regression test. Except that comparing all the pixels, it would mean that we need to have all the pixels of these 8 different images. So how can we make that faster, simpler? Maybe we reduce the size of the images. If we take these images, the picture of the user photo, and the doughboy images that we want to compare against, and draw them smaller and smaller and smaller, and reduce the scope of what we want to look at, the data we want to look at, the doughboy image in the end is really simple. It's just like, you could replace this gray and white by 0 and 1s, and then it takes nothing. It's like 6 by 6. It's really like 36 values. Then all you need to do is go pixel by pixel and compare. Is it the same gray or something else? Is it the same white or something else? And if it's something else, boom, you know that it's not one of these doughboys, and it's really easy. And then the amount of data you need to ship is much smaller, and the comparison is much faster. And I got to that thanks to these strange projects that I do, like where I play with Canvas, where I explore new APIs. So really, like these projects where I have fun coding, like useless things, it all comes together. When I do these small projects, and it can be about programming, it can be about making music, or about making games, making anything that is different from what you do at work. It all comes together, like you learn something, and you can bring it back to work. So if there's something, really, if there's something I would like to give you, or that you take from this talk, is that you should give yourself a space without mistakes. Like, go home and find your joy of coding. Like, find your craft, have fun, explore something, and worst case, you just have fun. You know? And in best case, you even bring it back at work, and it becomes super valuable. But really, just have fun. Find your joy of coding. And it doesn't have to take much time. Just do it when you can. With that, thank you very much.